What is Prelude FLNG, the largest man-made floating structure, doing in the middle of the ocean? How does this steel island, longer than 4 football fields and weighing exactly 600,000 tons, meet the energy needs of millions of people? It all began with humanity's relentless hunger for energy and the gradual depletion of onshore resources. Remember the oil booms in America at the beginning of the 1900s? The oil rigs spurting into the sky in Texas, and the massive cities that were established. Extracting gas and oil on land and transporting it to cities via pipelines was relatively easy because the ground you stepped on was stable and engineering calculations moved in a straight line. However, over time, it was understood that the richest gas reserves were hidden thousands of kilometers away from land, in the deepest and most treacherous parts of the oceans. The massive natural gas reserves discovered in the open sea, hundreds of miles away from the northwestern coast of Australia, whetted the appetite of engineers, but there was a massive problem. To transport the gas extracted from the seabed to the shore, using traditional methods, thousands of kilometers of pipelines had to be laid on the ocean floor, which was a daunting task that busted budgets and caused steel pipes to give in to ocean pressure. Steel could not withstand that tremendous deep sea pressure and the constantly moving currents at the ocean floor. It would break and leak. At that very moment of desperation, engineers put forward a radical and wild idea. They said, since we cannot bring the gas to the land, then we will take the massive refinery on land to the gas, to the middle of the ocean. The product of this thought, Prelude FLNG, is the world's largest floating offshore facility, measuring 488 meters in length and 74 meters in width, built at the Samsung Heavy Industries shipyard in South Korea and operated off the coast of Australia in partnership with Shell. Reaching a weight of 600,000 tons when fully loaded, which is equivalent to the weight of 6 aircraft carriers. This massive engineering marvel incorporates more than 260,000 tons of steel in its structure. Anchored to the seabed at a depth of 250 meters with a special turret system, the platform is protected against the harshest typhoons by a flexible weatherproofing mechanism that can rotate 360 degrees, taking a clever approach to cool natural gas to -162 degrees Celsius. This facility is a fully equipped floating factory with an annual processing capacity of 3.6 million tons of LNG, 1.3 million tons of condensate, and 400,000 tons of LPG, housing storage tanks with a volume of 175 Olympic swimming pools within its structure. Prelude FLNG processes offshore resources on-site without the need for onshore facilities and presents them directly to global markets. So what kind of energy does this massive floating titan consume, which both tries to move on the sea and processes enough natural gas to meet the energy needs of a city? Would it be a problem if it used a portion of the natural gas it extracts to move itself? Since Prelude FLNG is not a conventional ship traveling on the ocean under its own power, it does not have a traditional main marine engine or cruising fuel consumption. However, it houses a giant built-in power plant to operate the massive factory on it. All the electrical and mechanical power requirements of the facility are met by 3 Mitsubishi steam turbine generators, each with a capacity of 40 megawatts, located at its heart. And this engine system generates power equivalent to the electrical needs of a medium-sized city. The platform, which has a highly efficient and self-sufficient design in terms of fuel consumption, houses diesel generators for initial installation and emergencies, but during its main operational period, it uses a portion of the natural gas it extracts and processes from the seabed directly as fuel. While the factory systems operate with an optimized energy consumption rate of approximately 245 kilowatt-hours per ton, when the facility needs to be relocated, it is towed and floated by offshore tugboats, since it does not have its own propulsion engine. Nevertheless, the platform uses 3 stern thruster motors of 6,700 horsepower to maintain its position in stormy weather or when cargo ships berth, and to rotate like a weather vane against the current, and these auxiliary motors also derive their power from the electricity generated by the facility itself. Yes, we have understood the size of this massive machine and what kind of system it has. How can this ship, which has no connection to the land, store millions of cubic meters of natural gas from meters below the ground. If you like our videos, in which we explain the most exclusive technologies of the world's largest machines with simple 3D models, you can subscribe to our channel. When operating at full capacity, Prelude FLNG has the power to process and produce an average of 5.3 million tons of liquefied products per year, performing the function of massive factories on land alone on the ocean. This facility's annual liquefied natural gas production is 3.6 million tons. This amount alone can meet 117% of the annual natural gas needs of a massive metropolis like Hong Kong. While natural gas is extracted from the seabed and processed in the factory, it is cooled to a temperature of -162 degrees Celsius, shrinking its volume by exactly 600 times and converting it into a liquid phase. In this way, a massive amount of gas becomes storable in the tanks within the hull of the platform. Otherwise, it is impossible to create the space required to store such a large amount of gas. Inside the hull of Prelude, there are massive tanks customized for different products, with a total size that would fill 175 Olympic swimming pools. These tanks are prepared for different products and placed in the ship. So what happens when these tanks are full? Does this 600,000-ton ship have to disrupt the entire platform and berth to the land when the tanks are full? Since offshore logistics is designed entirely on a continuous cycle basis, the storage tanks of Prelude FLNG are never allowed to become completely full. When the facility is at full operational capacity, a massive LNG carrier cargo ship approaches alongside Prelude an average of once a week. A distance of approximately 4 meters remains between them. Special rotating and flexing cryogenic loading arms located on the platform are connected to the cargo ship. The stored LNG at -162 degrees Celsius is rapidly transferred from the Prelude tanks to the ship, emptying the storage. If, due to highly unusual adverse weather conditions or a logistical disruption, cargo ships cannot berth for days and the storage tanks reach the 100% fullness limit, the system automatically switches to production curtailment or a safe shutdown. Since the uncontrolled release of gas into the sea is impossible for environmental and safety reasons, gas extraction from the wells is temporarily halted, and the system is put into protection mode. Although it is anchored to the seabed, a refinery that is constantly in motion on the sea surface has different aspects than a fixed refinery on land. The crude gas extracted from the reservoirs beneath the seabed through high-pressure valves is carried upwards by means of massive steel pipes that can flex against currents and reaches the giant 93-meter turret system fixed to the seabed, located at the front part of the facility. Thanks to this turret, the facility can rotate 360 degrees according to the wind and waves without the pipes underneath being affected at all. The crude gas entering the factory on the platform is first purified from impurities such as water, carbon dioxide, mercury, and sulfur, then separated into light oil, LPG, and pure natural gas, and cooled. The platform utilizes ocean water as a vital resource to discharge the tremendous heat released during this massive liquefaction and freezing process and to cool the system. Prelude FLNG draws approximately 50 million liters of cold water per hour from the ocean to operate its cooling compressors steadily and efficiently. This water is taken from a depth of 150 meters below the surface through pipes hanging from the bottom of the platform so that it is not affected by the surface temperature and provides higher cooling efficiency. This drawn massive amount of ocean water passes through closed-circuit heat exchangers to absorb the heat of the natural gas, lowers its temperature without coming into direct contact with the gas in any way, and is then safely discharged back into the ocean in a heated state. Meeting the increasing energy needs, Prelude FLNG, which struggles with challenges both on the sea and under the sea, shows us the ultimate point reached by the level of engineering. See you in the next video.